Hey guys, my name is Angel Varela, and this is my presentation on ALE9 with enolates. I chose to do problem A, which says provide a valid synthesis for the product below. So anytime I start with a synthesis problem, I always look at what I start with and then what I end with. And I see that I have a 3-carbon molecule on the left, and then I have this addition here and an addition right here. So an addition to my carbon 1 and my addition to carbon 2. So right here, automatically, I see that we could do a, I believe it's called a 1,4 addition. And with this one, I decided to use, I believe it's called the organocuprate mechanism. And that mechanism involves the group that you're adding with a copper group and a lithium group. So what happens here is that one of the bonds will be added over here. This double bond will move over here in between. And then this double bond will be kicked off to the oxygen, producing a negative charge. And as you could see, this is the product that will be made. And then with this organocuprate reaction, we have 2 steps. One of the steps is the actual reagent, and then the other one is a workup step. The workup step will produce a carbonyl once again. And then from here, I decided that the best course of action would be to make this carbonyl into an enol. So to do that, I used water. And then after that step, for water, you will be making this alcohol with the double bond produced down here. And after that, you could also use I believe it's just an addition to the enols, because these lone pairs will be used for a double bond, kicking this bond off, but all these electrons will be used to bond with this methyl, which is an electrophile, because it's bonded to this iodine, which is a very, very strong nucleophile. And then what ends up happening is that we have this weird complex right here with this protonated oxygen. And then the 5th step includes pyridine, but I just wrote base. It basically, you just need a base to deprotonate your protonated oxygen. So then what happens is the base takes the hydrogen, and then the bonds used for between the oxygen and hydrogen get turned into lone pairs over here. Oh, for some reason I didn't write that out. It should just be this, which is the same thing as our answer, or as our product. So that's pretty much my thought process. Let me know if I did anything wrong. To me, I think I did a pretty good job at finding out what reagents you need and how to do it, but obviously, there's always room for error, so, yeah.